Hi Spring fans, welcome to another installment of Spring Tips. You know, my mom always told me to put my best foot forward. It's good advice. You gotta make a good first impression. Otherwise people aren't going to like you. They won't want to avail themselves of your, everything, right? Your services, your help, whatever. They're not going to want to be around you. And people liking you is a good thing. And you gotta be good to others. You wouldn't want to deal with yourself when you're in a poor mood, would you? I'll bet you're insufferable. I certainly can be. Although if I'm honest, I wouldn't even want to deal with myself when I'm in a good mood. I'm an idiot, and I cause myself no end of consternation with the things I get up to and shouldn't have, right? But anyway, that's neither here nor there. I think you can see what I'm getting at here. Friends don't let friends use PHP in production. Wait, that's the wrong soapbox. What I mean is, you want to make your APIs as clean and approachable as possible, right? The less cognitive work an API requires, the more likely it is to be used. This fact is a bit of a problem in the world of microservices, where suddenly every interaction is now a complicated network call. This is because you don't have the option of not using the service. You have to, but it's going to be fraught. So what we want to do is avail ourselves of things like reactive programming to make the call itself more robust, but the API can be better too. The proxy pattern can help us. Per Wikipedia, the proxy pattern is defined as an interface functioning as a pass-through to another more expensive resource, something that's hard or expensive to duplicate, like a file or a message queue or a web service or whatever. We can use this to work with other systems in a more approachable fashion. And we can even, with reactive APIs, avoid sacrificing the robustness and the data flow logic that we got. In Java, the proxy pattern looks like this. You have an interface declaratively connected to a remote service. So RMI does this. I think James Strachan had something for JMS in the early 2000s. Spring has a lot of remote procedure invokers. Spring integration messaging gateways qualify as this kind of a thing. Spring data repositories qualify here. Spring Cloud has a couple of them. It has Spring Cloud OpenFeign and Spring Cloud Retrofit, right? All of those are easy to use, but I've been wanting something that'll support RSocket. I love RSocket. RSocket is the protocol to beat for service-to-service communication. It basically reifies the principles of reactive programming and makes it so that you can talk, in all sorts of different messaging exchange patterns, one service to another. That said, I couldn't find a really good sort of declarative proxy kind of approach to building RSocket clients. Now, don't get me wrong, RSocket is not just a client service technology, it's actually a bidirectional technology. But still, if I'm building a client, if I want to have that use case, it'd be nice if things could be just a little bit easier. They're not particularly hard, but they could be easier. And so we're going to cover a technology today called Spring Retrosocket. It's an experimental technology that scratches this particular itch quite well. We won't go into the details about RSocket itself. I did another Spring Tips video on that. There's a much more in-depth dive into that topic. So let's get started. We have a lot to get to, and we have a very little time in which to do it.
All right, let's get into it. First things first, we're going to create a service. And so we'll do this, of course, by going to my second favorite place on the internet. We're going to go to start.spring.io, and we're going to create a new service called a service. And we're going to use, of course, Spring Native and RSocket support and Lombok support. Let's hit generate. That'll also give us a zip file that I can open up in the IDE. All right, let's go ahead and create a service. We're going to, it's a very simple RSocket service. We've already done a video introducing most of RSocket. So, if you haven't gotten the fundamentals there, please check that out. This is not so hard either way. So we're going to do 8181 as a port to create the RSocket service. By default, with HTTP, and if you have Spring Web Flux or Spring MVC on the class path, you'll get an embedded web server that starts up on port 880. By default, you have to opt out of the web server. Well, with RSocket, you have to opt in. You have to say, I want this port, and therefore it'll create a web server to run, or it'll create an RSocket service to make available your endpoints. And here we're just going to create a simple @controller, and we're going to call this the greetings controller. And here we're going to have a few endpoints that give us just a simple way to test. So we're going to create message mapping, hello, mono of string, hello. Okay, we'll say return hello world. And that's it. That's my RSocket endpoint. Oops, I need to wrap this in a publisher. All right, there's my simple endpoint. Let's go ahead and restart this and see what we get. All right, let's test this out. So we can use the venerable RSC command line utility. And the route will be hello. Okay, so there it is, hello world, it's working just fine. Now let's create a client to talk to that endpoint. I'm gonna do the same thing here. Native RSocket, hit generate, and we're gonna open this as well in the IDE. All right, so here's our new application. And we're gonna create a client. So let's do this the old-fashioned way first. So we'll say that we want an RSocket requester, RSocket requester.builder, and we want to build the builder to connect to our localhost 8181 endpoint. Okay, and now I want to build a bean that just gets run when the application starts up and uses that to call the other service. So application runner. I'm going to use the RSocket requester. Okay. Events, and we'll say RSocket requester dot route, and here the goal is to call the hello endpoint, and we're expecting some data back, and voila. So we got here a we want a mono, want a single value back, right? Not a stream. So we'll say retrieve mono. Okay. Okay, good. There's that. And we can just subscribe to it. We can say reply.subscribe and just print out the results, just like we would in any other reactive stream. Okay, so we've got our, basics runner, okay? It's gonna connect to that endpoint, take the data, convert it into a stream of one value, a mono, and then we're gonna subscribe to that value. Let's run this and see what we get. We have to make sure we keep the service running, otherwise it'll start and then immediately stop. So I'll just do in.read, and we'll add exception to that. Okay, there we go. So it's worked. We're now able to communicate. One side is talking to the other. So now, can we use Spring Retrosocket to make things simpler? Well, of course. I mean, we wouldn't be here otherwise, right? That's the whole point. So what we're going to do is we're going to bring in the Retrosocket client dependency. And right now that's in the snapshot and milestone repositories. It's not yet in GA. So that's okay though, because we've got native support on the class path here. And for the moment, that in turn also brings in, it configures the snapshot and milestone repositories. So then we just need to use the dependency. So we'll add Spring Retrosocket 0.001 snapshot. All right, there it is. There's it. It's on the class path. I want to set up support for RSocket clients, so we'll do that and enable RSocket clients. And then we can define an RSocket client itself. So RSocket client interface greetings client mono of string greet. Okay, and of course we want to map this to the same hello route as on the server side. And let's rewrite this now to use that new code, right? So instead of using the low-level client, we'll just inject the greetings client. And we can say gc.greet. And voila. So now we can go ahead and use the greetings client. Let's go ahead and restart. There it is. So that's working just fine. Okay, so now we've got a simple back and forth. You can parameterize the communication between the nodes. So let's go here and give it a name. So we'll say, okay, let's make it a parameterized, right? Name, destination variable, string name, hello name. All right, good. So there's this. That's a little bit more sophisticated. So we'll go ahead and restart. And then restart here. So now that that service is up, now we can go back and change our endpoint. So we'll give it a name here as well. And again, same exact basic configuration. In fact, you could probably extract out this interface to a shared jar and just share that between the producer and the consumer if you like. So now we need to also pass it a name. Spring Tips fans, okay. So there we go, we've got our response. Now, you might ask, since this RSocket requester is only going to make requests destined for localhost 8181, what happens if I have more than one RSocket requester and more than one interface? Well, you can pair them, and there's a couple of different ways to do this, but they're both basically the same. The answer is as you'd expect, to just use a qualifier. So let's say I wanted to create two different RSocket requesters. Okay, so we're going to call this one 1, and this one 2, because I'm really good with names, you can tell. Let's see what happens. There you go. So you can see there should be no more nor less than one unqualified RSocket requester, because of course the Retrosocket client can't determine what to do with it. So the way to fix it is just use a qualifier. So you say at qualifier, let's say 2, and let's say that's the one I'm interested in. Okay, so I go down here, annotate the interface itself, and suddenly it works. Okay. The other thing you can do to make it a little bit more, elegant, if you like, is just, to create your own meta annotation. So we can go here and get rid of this and just add at qualifier to, to RSocket. Actually, what is this? What is the endpoint that we're calling? We're calling this the greetings RSocket, right? So, give yourself a qualifier there. We can call this greetings. So it's the same as though I put the annotation and the string on each of the bits of code. Okay. So there's greetings RSocket, and then put this here, and then rerun. And that works as well. So using custom qualifiers makes it a little bit cleaner. You can do that if you want, or just use strings, or just use any combination of qualifiers you like. But that makes it easy to pair one interface with one RSocket requester. And so the idea is that you would have one client, one facade, one Retrosocket client for each RSocket service. The other thing that you may want to do is send metadata, right? RSocket supports this concept of metadata. So let's return to our service and set that up here. And the way metadata works on the service side is that you configure how to map a MIME type to an encoder, basically. And you do that with an RSocket strategies customizer. Okay, and with the strategies, given the strategies, we are going to contribute all the other ones that are there by default. So decoders dot add string decoder, all MIME types. Okay, so that's the defaults basically. But I also want to configure a metadata registry. So I'll say metadata extractor registry, and given a registry, I'm going to extract the data. So metadata to extract. So in order to use this, we need to set up a MIME type. So let's do that up here. Private final MIME type. And it'll be MIME type.value of. And I'm going to call this one, it's just a custom one. You can do whatever you like, right? So beautiful dot, whatever, client ID. Okay, so that's my MIME type. And private final. And then we want to have the actual, I guess we could actually extract that out, couldn't we? Or at least this bit right here. That's the header part that I care about. private final string ID. Okay, whoops. Okay. So that's those 2 bits. So now we can say, given this.mime type, we want to match it to strings, and we want to add the client ID header. So header. Good. Okay. So there's our basic configuration. Replace it with this registry. Good. All right. So there's your basic RSocket configuration there. On the server side, we also want to change this to accept a header, right? So the header will just be the client ID that we want to send, right? The client ID header itself. And that's basically this business here. So we want to say that this is the string client ID. And now we can actually enumerate that. We can actually just say, we don't need the name. Let's get rid of the name. There we go. So now the metadata in the message will tell us who to greet. We won't even have a parameter. You could do this, by the way, Spring Security uses the same exact mechanism. It uses metadata. So here we're making explicit the concept of metadata, but you don't have to, right? That's the genius of this thing. So we don't need this either. It's back to just regular old hello. Okay, let's go to this now. And we want to get rid of that. And instead, we want here, we want to inject the header, which is going to be based on the client ID, the MIME type, right? So that's this business. Get it injected. We're going to greet by the client ID. And if you wanted to send the payload, by the way, if you wanted to distinguish that, you'd do this, something like that, payload, right? So there's the parameter for the payload itself, but we don't need that. And then we go down and let's use it. So I'm going to change this code now to, Spring Tips fans will actually be the header. Okay, so basically it just happens to work in this case, but okay, so hello Spring Tips fans. So we sent a request containing the string over here to this service, and when we got the service, when the service came, we had the header, right? This is just one of the headers, but we can actually inject the whole map of headers by saying map string object headers, and then we can just enumerate all of them. So for each KV V, right? So this isn't Scala or TypeScript. And okay, so there's our service. Let's go ahead and restart this client. There's our service. Let's go ahead and restart the client. Oh, cool. So there's hello Spring Tips fans. And there on the server side, you can see it says client ID equals Spring Tips fans. So not only did it get communicated as an individual header, but it's also in the map of other headers, and it's being communicated by the client, but you wouldn't have to deal with all that. You don't know that. You just know that when you invoke this client from the application runner, you can pass in a string and it happens to satisfy, it slots into one of the headers that gets communicated over the wire. So we've got this very easy client facility. Now, RSocket is a bi-directional protocol, and so Spring Retrosocket isn't going to be great for bi-directional communication. You can still do bi-directional communication, but you're going to have to do it in terms of the RSocket requester and the controller handlers themselves. But if you want a really easy kind of RPC style client, this is very simple, right? And the nice thing about this is that the Spring Retrosocket project includes hints that allow you to use it with Spring Native. We did a very long 90-minute deep dive into all things Spring Native last week, so we won't rehash that this time. But you can easily use it, and we've already got Spring Native on the class path. So the Spring Initializer has pre-configured the Maven plugin for GraalVM and the Spring AOT plugin, and it's here that we can add the functionality that supports compiling our Retrosocket code into native code, okay? And so in order to do that, we have to bring in the Spring Retrosocket native library, right? And you have to add this to the dependency stanza of the Spring AOT Maven plugin. So with that there, we can then build the application. So we'll do maven -d skip tests -p to activate the native profile that's been configured in the Maven build to support GraalVM compilation. All right, it ran. Let's go to the target directory and run it. All right, there we go, 44 milliseconds. There's our Hello Spring Tips fans. And with that, we've had a quick look at Retrosocket, including the new Spring Native support. So you can build, crazy fast, super lightweight RSocket based services. RSocket is reactive, so it's the most efficient, most consistent, most scalable approach to building services today. It's a binary protocol, very optimized for performance. And now, thanks to Spring Native, you have a runtime footprint that it matches the efficiency of your code.